Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have 5 over m plus 6 over n equals to 7, and we solve this problem for the values of m and n, and here over m and n must be n integers. Okay, so the very first step we are going to do is here first we multiplying both of the sides by m into n. So we multiply the product of m and n on both of the sides, so that it will be written as mn multiplied by 5 over m plus mn multiplied by 6 over n equals to mn multiplied by 7. So now in the next step, here we need little bit simplification. So this m is cancelled out by this m, and here we get 5 times of n plus here this n is cancelled out by this n, and we get 6 times of m equals to 7 times of m into n. And now in the next step, here we need a little bit simplifications here, so that now first we move this 7m to the left hand side, and it will be written as, so here we move the terms in the left hand side to the right hand side, so that it will be written as 7 times of mn minus 5n. First we write just here minus 6m and minus 5n, and this whole equals to 0. So here you focus on first two terms, and here we just take common 7 times of m, and the remaining terms are n minus 6 over 7, because here we take common m on both of these terms. So here we have 7 is divided by here, so this will be written as minus 5n, and this whole equals to 0. So now in order to make this n minus 6 over 7 factor, so that here we need to add both of the sides by 30 over 7. So we just write here add both of the sides by 30 over 7, and it will be written as 7 times of m into n minus 6 over 7 minus 5n and plus 30 over 7 is equals to 30 over 7. Here we just add both of the sides by 30 over 7. So in the next step, we take common 5 from here, and it will be written as 7 times of n minus 6 over 7 minus, here we take common 5, and you get here n minus 6 over 7, and this whole equals to 30 over 7. And now in the next step, here we just take common n minus 6 over 7 from both of these terms, and it will be written as 7m minus 5 is equals to 30 over 7. So now in the next step, we multiply both of the sides by 7, and it will be written as 7 times of n minus 6 over 7 into 7m minus 5 equals to 7 times of 30 over 7. So this 7 is cancelled out by this 7, and when we multiply the 7 on both of these terms, it will be written as 7n minus 6 into 7m minus 5 is equals to 30. So here you focus on the left hand side, and we have two factors are multiplied by each other, but in the right hand side we have only one factor, so that here we make some possible cases in which you get the factors of 30. So here we have some cases. So case number 1 is when you multiply 1 by 30, then you get here 30, and when you will multiply 30 by 1, then you again get 30. So this is our first factor. And in the second case, we have 6 times of we have 2 times of 15 is also equals to 30, and 15 times of 2 is equals to 30. So this is the second case. And in third case, we have 3 times of 10 becomes 30, and 10 times of 3 becomes 30. And in the fourth case, we have 5 times of 6 equals to 30, and 6 times of 5 is also equals to 30. So we have in the left hand side we have two factors are multiplied by each other, but in the right hand side we have only one factor. So we get these 4 cases in which you get the product of two numbers is 30. So now we solve this problem by these 4 cases. So now first we solve this question by case number 1. So we compare the left hand side with these two pairs, and it will be written as 7n minus 6 equals to 1, and 7m minus 5 equals to 30. And similarly, the second value is we take 7n minus 6 equals to 30, and we get 7m minus 5 is equals to 1. So here this is our first case, and we first find the values of m and n from this case. So in the first equation we have 7n equals to, we move this minus 6 to the right hand side and we get 7. So here you easily get the value of n is equals to 1. So in order to find the values of m and n, you remember one thing is that our m and n must be n positive or any integer. Okay, so now we move toward the second case, the second value. So here you move minus 5 to the right hand side and you get here 7m equals to 35. So in this case you get the value of m equals to 5. So in both of these cases we get the integer solutions. So these are the first solutions of the given equation. So now we solve this one, and from this one we move this minus 6 to the right hand side and we get here 7n equals to 36, and we have n equals to 36 over 7. So here you see that this is not an integer, it is not belongs to z, so that we rejected this case because it cannot gives us the integer solution. And similarly here we move towards our case number 2, and here you see that in case number 2 we have this is the case number 2 in which we have 2 times of 5 is 30. So we compare these two numbers with 2 and 15, and it will be written as 7n minus 6 equals to 2 and 7m minus 5 equals to 15. Similarly, we take 7n minus 6 equals to 15 and 7m minus 5 equals to 2. So this is our case number 2, and now we solve this case and we get the values of m and n here. So first we move this equation and we move minus 6 to the right hand side, and it will be written as 7n equals to 8, and here you get n equals to 8 over 7. So this 8 over 7 is not belongs to z, so that we rejected this case. And now we can solve this case, and in this case we move this minus 6 to the right hand side and we get here 7n equals to 15 plus 6 becomes 21. So here you get the value of n equals to 3. And similarly in this case we move this minus 5 to the right hand side and you get here 7m equals to 7, and in this case we get the value of m equals to 1. So this is the our integer solution. So these both are integer solutions. Similarly, we move towards our case number 3, and in case number 3 we just compare the value of 3 and 10 in both of these numbers. So when you compare these two values here, it will be written as 7n minus 6 equals to 3 and 7m minus 5 equals to 10. Similarly, 7n minus 6 equals to 10 and 7m minus 5 equals to 3. So now we check these two cases and we get the value of m and n. So here we move this minus 6 to the right hand side and it will be written as 7n equals to 9, and here you get n equals to 9 over 7. So you clearly see that it is not belongs to z, so we rejected this case. And now we can focus on this case, and here we move this minus 6 to the right hand side and you get here 7n equals to 6 plus 10 becomes 16. So here you get n equals to 7 over 16. So this is also not belongs to integer, so we reject this case because this case cannot gives us any integer solutions. So now we move towards our case number 4, and in case number 4 we have the values is 5 and 6. So we compare these two factors by 5 and 6. So when we compare, it will be written as 7n minus 6 equals to 5 and 7m minus 5 equals to 6. Similarly, 7n minus 6 is equals to 6 and 7m minus 5 is equals to 5. So in the first case you get here 7n is equals to 11 and n is equals to 11 over 7. So it is not belongs to z, so that we rejected this case. and we can just proceed here this case, and in this case we move this minus 6 to the right hand side, and here you get 7n equals to 12, and this is n equals to 12 over 7. This is also not belongs to z, so we again rejected this case as well. So that finally we have just two integer solutions from, we get case number 1 and case number 2, and this is the final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.